Hi everyone. Today we are going to discuss about a practical to determine the refractive index of a glass slab using traveling microscope. So the apparatus required for these experiments are traveling microscope, then you need a glass slab with suitable width, you need lycopodium powder, and if you don't have lycopodium powder in your laboratory, then you can use chalk powder also. Then you can need a small piece of paper. Now let's discuss what is a refractive index. So we know that the velocity of light in vacuum is 3 into 10 to the power 8 meter per second. But if light passes through a medium, for example, if light passes through glass medium or water, then its velocity drastically reduces. So the ratio between the velocity of light in vacuum and the velocity of light in a certain medium is known as the refractive index. So refractive index is basically a parameter to show that how much the velocity of light reduces when it passes through a medium. Now you should always remember that since it is a ratio between the velocity of light in vacuum, and according to the special theory of relativity, the velocity of light in vacuum is the optimum velocity obtained by any particles. So you can say that the refractive index is always greater than 1, or it may be 1, but it cannot be less than 1. If it is less than 1, it means that velocity of light in a certain medium is greater than the velocity of light in vacuum, so which is not possible. So refractive index of any medium is always either it is equal to 1 or it should be greater than 1. Now since we are going to find out the refractive index of a glass slab or the glass material, so it is known that the refractive index of glass is near about 1.54, and since it is a ratio between the velocities, so it is a dimensionless quantity. Now if you look at this picture, so you will find that this is the glass slab. So ABCD is the boundary of the glass slab, and so O is the object which is below the glass slab. So considering the ray diagrams, the ray of light which is coming from the object O, so it will go to all directions, and we will consider only, for example, 2 directions. So this one is direction of the light, and this one is another direction of light which is coming from the object O. Now light always travels through a straight line in a certain medium. The ray of light which is coming from the O, so it will go through this direction, and at the boundary between the 2 medium, you can see this is the glass medium and this one is the air medium. So glass medium is denser compared to the air medium. So according to the law of refraction, so when light passes through denser medium to rare medium, so it will deviate, or it will direct it far away from the normal at the point of the intersection. Okay, so similarly, if the ray of light coming from this object O goes through the direction of the normal itself, so there will be no changes of the direction of the light. And if you extend the deviation of this ray, then it will intersect at the point I. So the object, so if you view it through this direction, so you will find that the object I is lifted at the position I. So this position I will be your apparent position of this object O. So an observer, the thickness of this glass slabs will be reduced to this much, that is A2 minus A1, or you can say A1 minus A2. So this A1 minus A2 will be your apparent thickness, and A1 minus A3 will be the real thickness of the glass slab. And from this ratio of this real and apparent thickness, so you can find out the refractive index by this relation, right? So this is a photograph of traveling microscope. So this will be discussed later again. So this one is this Q for slow vertical movement of this vernier scale. Then 2 is the eyepiece, where you will see the object, and this 3 is the vernier scale. 4 is the focusing screw to focus the object when you view the object through this microscope. And 5 is the horizontal vernier scale, which we are not going to use to determine the refractive index of the glass. And similar to screw 1, this screw 6 is also used for the slow movement of this vernier scale in a horizontal direction. And 7, 8 are the screws to make the platform of this traveling microscope horizontal. So before starting the experiment, so you should understand what is a least count, and you have to find out the least count of your instrument, that is traveling microscope. So least count is basically the minimum distance a traveling microscope can measure accurately. So this is basically similar to the vernier scale which we have done before. So least count is basically the difference between the one main scale division to the one vernier scale division. So this is the procedure to find out the least count of your traveling microscope, and you should always remember that least count of instrument, that means the least count of your traveling microscope, is different for different instruments. That means for different traveling microscope, the least count may be different. So in this case, the least count is 0.001 centimeter. Now let's check how to find out the least count of your traveling microscope. So first you have to figure out how many numbers of main scale division is equal to 1 centimeter. So from this you can easily find out the one main scale division. So for example, if you have 20 main scale division is equal to 1 centimeter, then one main scale division will be 1 by 20 centimeter. Now if you carefully observe the vernier scale attached to your traveling microscope, and if you find that the 50 vernier scale divisions is equal to 49 main scale division, then one vernier scale division will be calculated like this. So the least count you can find out like this way, and for this example, the least count we have observed that it is 0.001 centimeter. So this is traveling microscope. This is the speed level, and this is the glass slab which you are going to find out the refractive index. This is a piece of paper, and this is the tab to fix this paper on this platform of the microscope, the traveling microscope. So first what you have to do, you have to make the horizontal of the platform of the traveling microscope by this speed level, and you can do this by these two screws. you can adjust these two screws to make the platform of this traveling microscope horizontal. Now you can see the platform has been horizontal. Now this is the vertical main scale, this is the vertical vernier scale, and this is the vertical main scale, and similarly this is also the horizontal vernier scale. And for this experiment you don't need the vertical, you don't need the horizontal scale, you need only the vertical scale. Now by this screw you can move the telescope, in a upward or downward direction, and this screw you can use to for slow movement of this telescope. And you can see when you rotate this telescope rotate this screw clockwise or anti-clockwise, it moves upward or downward direction. So this is also the screw to move the horizontal direction of the telescope. So first for this experiment, first you have to take this piece of paper, then by your pen you have to mark a crossing on the paper, and this paper is like this, and this paper you have to fix on the platform by this plastic tape, and you have to focus this cross mark very carefully by the telescope. So you see you have to focus it very carefully. You can focus by rotating these screws, and for alignment you can use this other knobs also, so that your telescope should be vertical. And now I am trying to focus the cross mark, and it's almost done. And one thing you should always remember, that once focus the cross mark, you never try to change the focus again. So now you can find out the vertical scale, vernier scale reading. Okay, in the second part of this experiment you have to place this so you have to fix the paper by this tape, and in the second step you have to place this slab on the piece of paper. Now according to theory, as we have seen in the theory, now the cross mark will be elevated, or it will be lifted upward due to the refractive index of the glass. And now again you have to focus it very carefully, and once it is focused, then again you have to mark the vernier and main scale reading. So this will be your apparent image. Like the eye which we have seen in our theoretical explanation. Now in the third step, what you have to do, if you don't have lycopodium powder, you have to use chalk powder, and you have to scatter this chalk powder on the top surface of this glass slab, and again you have to focus on the particles of the chalk powder. But remember, this time you don't need to focus the cross mark. You have to focus only the particles of the chalk powder. So you have to do it very carefully. So once it is done, then again you have to mark the vernier as well as the manicure ready. You have to mark out. And all three steps you can see that we have not used the horizontal, vertical as well as the manicure. So this is the results of the experiment. So first you have to find out the vernier constant or the least count of your vernier scale. Then you have to figure out this table. So like the experiment has been explained, so you have to find out the corresponding readings. So first we have to find out the cross mark without the glass slab, and you have to write the vernier as well as the main scale reading. Then after placing the glass slab, you have to again find out the vernier and main scale reading. Then once you have placed the lycopodium powder on the upper surface of the glass slab, then you have to write down the vernier as well as main scale reading here. And then for real thickness you have to subtract A3 from A1, and for apparent thickness you have to subtract A2 from A1. And so from these two readings we can find out the refractive index, which is the ratio of the real thickness to the apparent thickness. And similarly you have to find out a refractive index for different positions of the cross mark. And once you get the readings, so you have to take the mean, and this mean will give you the refractive index of the glass slab. So when you do the experiment, you have to take few precautions. The precautions, number one is that the parallax in a microscope should be removed properly, and to avoid backlash error the microscope should be moved upward. And there are some sources of error, so you have to take care of this error. The scale used in this microscope might not be calibrated properly, so you have to check it very properly. And the lycopodium powder layer on the glass slab might be thick, so when you put the lycopodium powder or the chalk powder on the surface of the glass slab, so you should always take care that need to take care that the thickness of the lycopodium powder layer or the chalk powder layer should not be very thick, otherwise there will be a error associated with the measured refractive index.